Hello everybody, welcome back. We hope you enjoyed the previous session by Marcus. Coming up next we have Mladen Pradish with optimizing database access and diving into the .NET SQL clients. This 24-hour PaaS event contains 24 live sessions by expert speakers from the PaaS community from all corners of the world. All sessions will be recorded and made available in about a week. And slide decks are already available if you go to 24hoursofpaas.com. And my name is André Mancia. I will be moderating the session, and in the end of the session I will be taking your questions and presenting it to Mladen. Before starting the session, we have a few slides of information for you. So if you need any technical assistance or just simply want to ask some questions, just put them in the chat clients on the webinar panel, and you feel free to ask the question at any time, and when it is convenient, I will ask them to Mladen. You can also use the Zoom controls to maximize your viewing window, and at the end of the session, we just ask you to fill in a small evaluation form. Your opinion is important. Please fill it out. Okay, so we would like to thank the sponsors as well. So we have Microsoft and Idera, and also Attunity. Attunity is a leader in data integration and management software, which helps move, transform, and analyze data efficiently in SQL Server and Azure environments. Check out their handout in your control pane for more information about Attunity, and also a chance to win an Amazon Echo. In addition, we'll also like to thank Hewlett-Packard Enterprise and SQL Sentry, which are also supporting sponsors. Also, 24 Hours of PaaS would not be possible without all their support and contributions, and they are the reason this event is free of charge. Also, join us, oh sorry, previous slide. Please join us at SqlPaaS.org. We have a lot of information for all kinds of data professionals. We have local user groups around the world, special interest groups, and you can find free online resources through our Learning Center and read up on the latest community news in the Connector newsletter. Okay, so you're still in time if you want to go to PaaS Summit. It takes place in Washington, in Seattle, Washington, from the 25th to the 28th of October. And you'll have 200 sessions with world-class experts. You can actually save 200 on registration if you use the exclusive code on screen, which is 24HOP200. If you want to find out more, just go to PaaSSummit.com.
Okay, so my turn or your turn?
I can talk about you for a bit. Okay, so I would like to introduce you to Mladen Pradish. He's from Slovenia. He's a SQL Server MVP, and he has been a C# and SQL Server developer for over 15 years. You'll obviously see a few slides with his blog address, which is weblog.sqlteam.com/mladenp. And he's also the developer of a very popular add-in for the Management Studio, which is called SSMS Tools Pack, and you can have it in ssmstoolspack.com. So without further ado, here's Mladen with the session.
Okay, thank you, Andre. So welcome everybody. Today we'll be talking about client access. So we will mostly be in .NET and what you can do in .NET to optimize your data access, because mostly everybody talks about how to make your applications, etc., faster on the database side, but nobody talks about the gotchas on the client side and what you can do to improve your app performance. So first, a disclaimer: I use select star in demos only for brevity, because you should never use select star. And if you are a DBA and you want to prevent everybody from using select star in their queries, there's a little cool thing that you can do, just add a computed column to your tables that says select 1 divided by 0, and everybody that does select star will result in error because you cannot divide by 0. Okay, so what we will be talking about. First, we will talk about how the client data access works. So what does the application have to do to actually connect to the client, and how do they communicate with each other? Then we'll look at the new exciting stuff since .NET 4.5, which is the async SQL data reader, and how that works, and why is a good idea that you should use it, because it makes a lot of stuff much more simpler. Then we'll be talking about transaction management with transaction scope and the gotchas you can have there. We will talk also about connection pooling and what you have to be very careful about when doing connection pooling, because connection pooling is used in .NET by default. You can turn it off, but it's used by default. We will talk about batching commands when sending them to SQL Server, and we'll see how that can speed up your app 2 to 10 times. In the end, we'll be talking about statistics. So this is not the SQL Server statistics, but the statistics on the client. So what you can do is basically for each connection you make, you can get the network packets, bytes received, queries executed, etc., etc. statistics. So you can aggregate all this on the client and get a very good idea what your application does. And then in the end, we'll talk about the new 2016 stuff, which is always encrypted, but we will look at it only from the client side. So we will not talk anything. We'll look at it, what it does on the client side and how to use it on the client side. Okay, so to start, this is the only correct way, in my opinion, well, the easiest also way to use a SQL connection. So basically what you have to do is put a SQL connection in .NET in the using statement, open it, and then read from the server, return, execute queries, etc. Now, why is this the correct way? Is because a connection object can be disposed. So it's not it's basically a object that you have to dispose. Otherwise, it gets stuck in memory, and by using the using statement, it automatically gets disposed. And when it gets disposed, it also gets closed. So you don't have to do any kinds of connection close or connection dispose by hand. So the using takes care of that, and it's simple to do. So client data access, how it works. Basically, when you connect to the SQL Server with any kind of client, the two communicate via something called a TDS. It's called a tabular data stream, and this format of communication is actually really well known. There's even an open source implementation of it called, I think it's OpenTDS. And the way this works is if you if you send two queries in the same command, like here in the example, select star from table 1, select star from table 2, what you will get back is result set for each of the queries, and behind every result set there will be something called a done token. There is some extra stuff in there that TDS takes care of, but basically you can think of it as a done token. So when you get to the done token, you will know that consuming the result set has finished, and you can go to the next result set. Now, each result set is comprised of row data, right? So when each row starts, there is something called a row start token. So each row has its own row token. And each row is basically comprised of a column header for each column and a column data. So we can see that the column headers are all equal sizes, but column data can be different sizes. Column headers are all the same size, but column data can be different sizes depending on the data type, right? So if you have a data type integer, the column data will always be 4 bytes, right? If you have a char 50, there will always be 50 bytes in the column data part. But if you have something like an nvarchar max, you don't know how big that can be. I mean, it can be up to 2 gigabytes, so you can have like a 2 gigabyte column data part. And this can be problematic, which we will take a look at later. So there are two ways you can access your SQL Server from .NET. The default access is something called a non-sequential. So this is something you get by default when you call command SQL command.execute reader. The second part is sequential access. Basically, you have to put the flag command behavior sequential access into the execute reader if you want to get that kind of access. Now, the way they differ is the default, so the non-sequential access. Basically, if you have 3 columns of data and if you want to read the last column, basically you read the whole row of data into memory, right? So it means that this is the default access. We're all familiar with this. So you read all the column, all the row data into memory, and you can access columns however you like. You can go back and read the previous column's data, and you can say data reader value of column 2, and then data reader value of column 0, and then data reader value of column 1. Right? So it doesn't matter. The order of accessing columns doesn't really matter. So basically, the full row is stored in client memory. You can move back and forward in the row. But if, for example, you have a large, say, binary columns or textual columns, something that is more than, say, a few megabytes in size, you can run into scalability issues, because if that row gets stored, the full row gets stored in memory, and you have multiple clients accessing the same table, your web server can get memory fragmentation, right? Because the chunk of memory is reserved, the row is stored in that chunk memory, and then it gets garbage disposed. But the memory management sometimes gets fragmented because of these things, right? I have actually seen at a client a few years ago, I have seen that they had this issue because they were reading large columns of data, about 100 megabytes each, and they solved this by using sequential access. So the way the sequential access works is basically, if we have the same scenario, we want to read the last column. We first have to read the first, the second, and then we get to the third column. But the problem is that in sequential access, as the name implies, is forward reading only. So if we say read column index 2, we get the value, and we then say read column index 0, we will get an error, because it is sequential access. We have already passed columns 0 and 1, so we cannot go and reread them back. So basically you have a streaming access of data, which you cannot go back, because you cannot go back in a stream. Therefore, in memory on the web server, the memory footprint is very small, because at one single time there is only one single column data stored in memory. So sequential access, basically only the current value is stored in client memory. You can only move forward in the row. SQL data reader has get star, so get integer, get char, get varchar, etc. methods for getting that data sequentially. Before .NET 4.5, the only way you could read blob columns, so nvarchar, max, var binary, etc., XML columns, you had only get bytes and get chars, right? Functions for blobs. So basically what you had to do is save it to a stream by reading it in chunks. So what you would do, for example, read the first column, then get the second column value that is binary, because we have to pass the first column, and then you would loop on this value to get the whole column out in chunks, and then you would have to save those chunks into a byte buffer or file or something like that. Now, .NET 4.5 makes this much easier. It gives you full streaming support for these types of this type of access. Basically, you have get stream, get text reader, and get XML reader. Basically, you have no more chunking of data by hand. And turns out this is really, really good for multi-machine ETL or large data transfers. So, for example, if there's a reason that you cannot use SSIS for some sort of ETL, you could make like a multi-machine batch process that would just flush your data from multiple sources into a single table or something like that. And about, well, just after, a bit after .NET 4.5 came out, I did this kind of solution for a client that, for reasons unknown to me, they couldn't use SSIS, so they had to use a large multi-machine ETL. The way this works is basically this ETL part is you get a binary data from source table, so that's of our binary max, and you want to insert that same value into the target table, right? So bear in mind that we are not talking between two servers. We can also be talking between two databases, but all the communication will have to go through your client data type, so everything will go through .NET. So sure, this adds a complexity of another machine in the mix, but sometimes this is the only way to do it. Then, because it's a max data type, we have to set the parameter size to -1, because -1 indicates it's a max data type. And then what we do is we basically execute reader in sequential access to the source data, and then we read that source data with reader source.read, and then we basically just get a stream of data from our binary data column. We put that data stream as a parameter of this stream parameter that will put the data into the target, and then on the target SQL command we just say execute non-query because we're not returning anything back, and this will basically work until all the data from the source has been read and inserted to the target. And you can see, if you do this, you can see that the memory footprint on the .NET machine is only as large as the largest of the column that you've read. Okay, so let's, just a moment. Okay, let's go to the new exciting stuff that is async SQL reader. Now, when you open a connection to your database, basically you don't want your UI in your app to block, right? So if your UI blocks, that's bad user experience. So the way we solved this until now, basically you had maybe a layer that talked to the database, like a database access layer or something like that, but in general the pattern was you would run a async SQL command with begin execute reader that would run in a background background thread, and you would get some result that you had to wait on, right? So in your UI you had to periodically check if that asynchronous execute reader function completed, right? If you used background worker, you would get a callback. But in general, you had to wait for it, and in the UI, you could do whatever you wanted to do. And when you get the notification that it completed, you would basically read the data that you got and show the operational result in some function. So that's basically an old way of doing things, right? So what exactly is this new stuff, right? It was made in C#, in .NET 4.5 to basically make async programming much easier. The good part is that it supports easy cancellation. So when you start it, you get something called a cancellation token, and you can just say cancel this operation with this cancellation token, and it will basically cancel. And what it does is it uses the new async and await keywords. So basically before, when you pressed a button, for example, in your app, before you would do something like this code shows. You would put a notification in some text box or UI element that would say, okay, we are starting a long operation. And then if you did it on the UI thread, this would block the whole UI thread, the long operation completed, right? And then when it finished, you would say, okay, this operation completed in X seconds. The problem was that you could not do anything with your app because the UI thread was busy doing basically nothing. So this async await keywords were added so that we can basically offload long I/O bound operations into the hardware that actually does it. So if, for example, we are reading data from the network, this has nothing to do with the CPU, right? So what this does is it says, okay, I'm going to start this long operation. You have to go to the network card to read stuff anyway. Until you, since you're doing that, return the control of the UI to me. So an interesting thing is that there are no background threads here. So if you want to use async and await, you simply do this, right? You put async in your custom event handler and await for your long I/O bound operation. And the good part is that it makes code async without complex threading code, right? The catch is that no threads are created by default. So everything still happens in the UI thread, but because we have offloaded the waiting work to the network card, for example, or to the disk, our CPU can be used to process the message loop of the application itself. So the default to use this is for I/O bound workloads, right? So if you have something like long disk reads or long network reads. If you really want to create background threads, you can use task.run to create background threads for CPU bounded workload. And the good part is that this is fully supported by Entity Framework 6. So if you're using Entity Framework 6, you can use this without issues. I don't know about support from different ORMs, but that's it. So if you want to learn more about this, and to be honest, you should if you do any kind of client development, there's a white paper from Microsoft called Asynchronous Programming with Async and Await. And it's a long white paper and goes into all kinds of depths on how this works. So the question is what to use when, right? So what are the good use cases to using the whole async stuff or using the normal stuff? So in either access modes, either sequential or non-sequential, prefer to use next result async. Why? Because when you're reading the result set, you're reading it, and you get to the TDS tokens, those TDS tokens between result sets can be processed in async, right? If you don't use the async part, they will be processed in sync, so your thread will, of course, block. Prefer read async in either access mode. So when you're reading the data from the data reader, just use read async all the time. Why? Because if you think of a single row that spans multiple network packets, and the default for the network packet, the data packet is 8K, you have something again called TDS tokens in between packets in a single row. So TDS tokens between multiple packets can be processed in async, so no thread blocking will happen. But it processes column data only once and not every time new column is accessed. So this is something that not many people know, but if you say read column 0, it will process the column metadata, right? So it will have to go through that column metadata. If you say read column 1, it will process the metadata of that column, right, etc., etc. With async, it can process the metadata for all columns only once. So this is the way to reduce this overhead. Now we get to the is DB null and get field value, right? So here, if you're using read async in the default sequential mode, use the is DB null and get field value because the data is already in the client buffer, right? So if you remember in non-sequential mode, all the data from the single row gets stored in the client buffer. So there is no use of using isDB null async and get field value async because we already have all the data in memory, and there is no use for the overhead of creating extra objects with the async methods. So use the isDB null async and get field value async only in sequential mode if your target column is large or if you need to read past large columns, right? So. And of course, if you want to read huge columns in sequential mode, like 1 gigabyte column of binary or something, just say get stream of the column index and copy to async to the output stream. And that's basically it. So a little demo of how this, very simple demo of how this works. Here I have the best demo app that you have ever seen. And what we'll do is, we'll first show the sync data reader, and we will open just a, say, long DB operation. We'll just put wait for delay for 5 seconds. Right? So what we'll do is, We're going to run the sync reader. And we can see that we cannot, I'm trying to move this window, but we cannot move it, right? So now I can move it after it has completed. So why has this happened? Because we have blocked the message loop of the UI thread. So only after it finishes can you start processing those messages again. But if I do the same thing with an async reader, so if I just do new SQL connection, I do connection open async and execute scalar async, and that's all the changes I've done. So you can see the differences in code here. So connection open and execute scalar, connection open async and execute scalar async. What I can do is, no cheating, I can still move this around because my long I/O bound operation has not affected my message loop, because this whole async await framework said, okay, we don't need to have our CPU idle, so we can use it to process messages. So if you want to, for example, okay, so to move on, so transaction scope. If you're not using transaction scope, so basically transaction management in .NET, you can do it in two ways. You can either use transaction scope, which is very easy to use, or you can use the iSQL transaction interface, and then you had to put that iSQL transaction interface to the connection and move it between connections if you wanted to have multi-connection transactions, etc., etc. Transaction scope makes this very easy. Basically, this is all you have to do. You say using transaction scope, using SQL connections, SQL connection, do stuff with your data, and then at the end use transaction scope complete. If anything, any kind of error happens or anything like that, this transaction scope complete won't execute, and because it won't execute, it will go, the transaction scope will go into its dispose method, and it's because of the using keyword, it will go into its dispose method, and in its dispose method, it will call a rollback. So this is basically all you have to do for transaction scope management. So it's easy to use, it keeps code simple, it's really great transaction management out of the box. The only downside is that it escalates sometimes to DTC. So there's a typo there. There should be Microsoft Distributed Transaction Coordinator. So basically it always escalates to DTC unless you're connecting to the same database with non-concurrent connections. What this means is that the default use of the way we're using connections to our SQL Server doesn't change. So nothing changes if you use it the same as you use it now. So basically, concurrent connections mean that you open the two different connections in the same transaction scope, which I will show you later. And if you're using transaction scope, you can see something called transaction unit of work, which is a GUID that gets assigned by the DTC if the DTC is being used, and you can see that in the sysdm tran active transactions dynamic management view. Now, here's an issue with it. The default isolation level is serializable. Now, you may think that this is an issue or not, but the default is because it uses DTC, and because the DTC has to coordinate between multiple machines. This is the best way of performing this coordination reliably, right? You can change, of course, to the isolation level to whatever you want in the available isolation levels, but this is the default. And why this is potentially problematic, we'll take a look at in the next segment. So let me show you how this works. So basically what we'll have here is transaction scope. What I'll do is basically use using the transaction scope, open, using two connections to two different servers. One is 2012, one is 2016, and I will open two connections at the same time, and I will close two connections at the same time. Next, we'll do, okay, so let's just run this. Transaction scope. So let's see what happens here. So I'm opening this one, and I'm opening the next one. And so both of them successfully opened. And if you look at the DTC coordinator, you can see that there's one active transaction and one has been already committed. Total is 2. Now, one has been already committed because I've ran this thing before the session, so one has came from before the session. So you can see the total transactions are 2. So if I now close these 2 things and say complete, I will see that here I have committed 2 transactions. Total is 2, so we have seen escalation. And I'm connecting to a different computer in my management studio, in my Hyper-V virtual machine, and we can see that we have total of 2 transactions here as well. So we have escalated to DTC. Now, so we are here connecting to 2 different servers. Now, if I connect to single server but to 2 different databases, and both connections are not opened at the same time, we'll see, but we are still inside the same transaction scope, we can see that the escalation still happens. So I'm connecting here to the server in my virtual machine. Open, complete, and we can see that total committed will now change to 3. So we have again escalated, right? Now we will go to a single server, one database, so single server, single database, but both connections will be opened at the same time. So open, open, and when I do the, I don't have to call close because it will be closed by default when using ends. I say transaction complete, and if I go again here, I will see that the total is 4. So again, we have escalated. Now, if I go to single server, single database, but both connections are not opened at the same time, so I say open, close, which is basically, if you think about it, this is the default way that we're using it now already. So if you start using transaction scope, not much will change for you. We'll see that we just do this and there will be no escalation. So if you remember, we had 4 before, it has not increased to 5. So there has been no escalation to DTC. So this is a good thing. So if you replace your transaction handling code right now with the transaction scope, for example, you're most likely that no changes will be needed to the app. Okay. So next, we'll talk about connection pooling. Now, connection pooling is very good from the point of view of a .NET application. So basically, a connection pool is created per process, so per your .NET process, per application domain, because a process can have many application domains, per connection string, which is very important, because if you have 2 connection strings that differ, even in a single space in the connection string text, they will create 2 connection pools. And per Windows identity. If you're using integrated security, and if you use different Windows logins to use to connect to the database, each login will have its own connection pool. The default max pool size is 100. So you can change this if you want. You can change this to, for example, 2, but 100 is a pretty good default. And if you want to monitor if your connections are pooled or not, you can do that via Profiler or Extended Events. Basically, in audit login or audit logout events, there's an event subclass column that can have values of 1 or 2. And 1 means non-pooled, so 1 will be when you first create the connection. And the 2 will be pooled, which will mean that it will be returned from the pool. And the way this works is basically when you create a connection, you close it, you dispose it. This connection will not be fully disposed and garbage collected, but it will remain in this connection pool for the duration of the time that you're trying to, the time that you're using your app. So when you try to open the same connection again, the whole infrastructure of the connection object doesn't have to be rebuilt, but it is just taken from this connection pool. Now, when you say open close on the connection, each time you will see something called a SP reset connection. This is stored procedure that will be, if you've ever run a profiler with the standard default template, you will see a lot of these SP reset connections. Basically, what this stored procedure does is exactly what the name implies. It resets the connection for reuse. So there's a long list of what it does on the next slide for reference, because this long list sometimes gets moved through MSDN, and it disappeared for I don't know, a few months. I mean, you couldn't see it. So, oh, it seems we have a question. No? Okay, so it says, okay, just Andre saying, feel free to ask questions. So yes,
yeah,
you can ask questions
exactly.
if you want to. Yeah. Okay, so let's minimize that. So here's the catch. This SP reset connection does not reset the isolation level, right? So this means that you should always, 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 and I cannot stress this enough, always explicitly specify your isolation level in your applications. Why? Because your the default isolation level is read committed, right? So this is a good default. It's okay. But remember when we talked about transaction scope, what's the default isolation level there? It's serializable. So now imagine what happens. So this is the connection pooling resets. So imagine what happens if you use a connection with the transaction scope and you do not specify the isolation level explicitly. It gets escalated to DTC, or because it's using transaction scope, it will be serializable. You close this connection and then you reuse it, and that connection that has come from connection pool still has the serializable isolation level. So even if you do not maybe want to have a serializable isolation level, you will have it. And if you do this for, say, multiple users, and everybody has just by default starts upgrading quoted to serializable, you will see immense blocking and your application will crawl to a halt. So basically always specify isolation level for your transactions. This is a good practice. This is good practice of coding, basically. Now, the good thing, in my opinion, was that in SQL Server 2014, Microsoft fixed this. So SP reset connection resets the isolation level as well. And I was happy and everything was well. Until SQL Server 2014 Cumulative Update 6, which changed back to the original behavior. The reason for this was that basically this was a breaking change, and if your app relied on this behavior, your app would basically change and you wouldn't know why. So I personally think that this setting is wrong, that this should be configurable, which is not at the moment. But again, always specify your isolation level. No matter what you do, always specify that. So now let's see just how this works. So if I say transaction scope, no, not transaction scope. Sorry, wrong button. Let's just skip to here. If I say connection pooling, I am connecting to the SQL Server 2016. So what I'm doing here is basically just saying if my isolation is null, just don't use any transaction scope. But if I'm using an isolation level, use the transaction scope. So basically, I connect to the server depending on my transaction scope value, and I check the transaction isolation level for this connection. And basically, the default, so I call it like this. I call it null, so there will be no transaction scope. I call it with serializable, so I explicitly specify the isolation level, and then I call it again with null, so I have no isolation level and I have no transaction scope. So what happens here is the first one is read committed, so I have no transaction management of any kind in this one. So isolation level is null, therefore transaction scope is null, and my isolation level is the default of read committed. Then I get this same connection from the connection pool. I specifically set the isolation level to serializable, so this is good. I have the serializable. I close the connection. I reopen that connection. So again, I have gotten it from the connection pool, but with null isolation level. So it's same thing as here. So there is no transaction management, no transaction scope. We see that this isolation level is again serializable. Even though you would assume, by my logic, by my reasoning, that it would have to be read committed because it's the default. But we can see the SP reset connection does not reset the isolation level, therefore it's serializable. So always do this. Always specify your isolation level, whatever your isolation level is. Okay. So next one, batching commands, how to make it go faster. Now, by batching commands, you basically optimize network round trips. of course, if you can bulk insert data, use that. So that's a streaming data insert. You have in .NET, you have something called a SQL bulk copy class, and you just pump data into this SQL bulk copy class, and it gets inserted by streaming into the data table. Now, the downside of the bulk, this bulk insert, is that it only works in a single table for a single table at a time. Now, a few years ago, I had a client. They were basically a sort of an aggregator of data for multiple web shops. Basically, web shops would get their purchases made, so their commerce on the web shop, and all of this was sent to this single system. And this single system would have to import this data into the SQL Server. Now, they had the normal way that we all do. Basically, they had 1,000 rows of data that they had to insert into different tables, and then basically they could just do 10,000 round trips, because you said, okay, insert this row into this table, this row into a child table, and the third row into another child table, because this was done for a single customer, right? And you could use the stored procedure, etc. But it required a lot of round trips. So, for example, for 10,000 inserts, you would need 10,000 round trips. So this is the most naive way of doing things. The next thing you can do is basically have 10 batches of 10,000 concatenated insert statements. So you just say insert statement 1, comma, semicolon, insert statement 2, another semicolon, insert statement 3, etc., and have just these 1,000 insert statements into a single string that you send to a SQL command. And this would make 10 round trips, but your string of data would be quite large. Now, there is something, so this would basically be 1,000 CSV SQL statements in one command. There is what I call a hidden gem in .NET, but unfortunately, for some reason, and this is being used by SQL data adapters, unfortunately, it's not public, right? So it's called SQL command set. Now, SQL command set is an internal class in the .NET framework. The way you could use it is basically to create your own wrapper around it, use some reflection on it to create the necessary commands. Luckily, this has already been done and is online, so if you Google SQL command set, you will get to a GitHub repository that contains this class. So I have basically just taken this class from there. And what it does, it gives you access to this SQL command set class. And we'll see what we'll do is we will basically have two tables, and we will transfer data from, no, sorry, wrong command batching. What we'll do is create a table called test batching and just insert 10,000 rows into it. So let's run this. Oh, it's already in there. Okay, cool. 5. So I can see that I have no rows in there. And what I'll do is simply, run this batching thing. So first I will insert 10,000 single inserts. Then I will do 10 times 1,000 concatenated inserts, and then I will do the command set. So let's see, this will take a few seconds. Batching commands. So 10,000 inserts will take, should be between 5 and 10 seconds, something like that, depending on the slowness of my VM. So this would be a good time for questions if you have them. Drawing tools menu now.
Well, okay, so far no questions.
No question. Okay, so it took about 18 seconds, and we'll see how long the 8 seconds and command set will take should take about 5. 7 seconds, okay. So this is because there is no cache happening or nothing. So this is just pure insert. So we can see that single inserts take about 18 seconds or 19 seconds. If we concat them, we basically get half speed here, right? So we improve our speed by 50%. And if you use the command set, you even get 2 seconds, a second and a half to 2 seconds more speed, so another 25%, right, of the previous 50% improvement. So basically, if you use this, and if you have a lot of inserts happening, you could batch them together, and this will improve your speed by half if you think about it. So if I try running this again, we'll see how long it takes. But in general, so you can also tweak the number of commands in this command set or in the batch, and you have to tweak it for your environment. But I have seen improvements of over like 500% improvements. So yeah, so to move on, let's just finish this. Okay, come on, 7. So it is faster. Okay, so the next one is statistics. So what is the app doing? So basically, you can enable client statistics per connection. They are cumulative for that connection while it's open. Once it's closed, it gets flushed. And it's good for tracking the actual database access from the app itself. So you could track this from the server, of course, but sometimes you have multiple apps and you want to track per app. So you can enable this in your app and then put this tracking info, for example, in the queue, and then on the client, and then process this queue on some interval, right? So you would get the actual access statistics from your app. And this way you can analyze historical access data. And just to show you how this works, client stats, so what I do here is I simply say select star from sales order header 2 times. That's it. I just do a while loop 2 times. And you can see that select rows 31,000, etc. And here in run 2, I get select rows 62,000. And you can see that this is equally divided by 2 because we did 2 runs. So this one is cumulative to this one. So execution time was first 59 milliseconds, and then there was 76 minus 59 milliseconds, etc., etc. Right? So this is cumulative, and you can save this into the client. Into the queue somewhere. So this is an interesting thing to have. I have not seen this being used a lot in various apps, but it's a really good thing that you can do. Okay, so next one, always encrypted from the client side only. Basically, there's not much work. You need .NET 4.6 for it to work. If you want to have custom key store providers or use bulk copy, you need to have 4.6.1 .NET. The way it works is it enables a secure key store access, so only the client can access its key for decrypting the data. Right? So I'm assuming that you know how always encrypted works on the server. So you enable it from the client. You enable it in 2 ways. You can either have a connection string option that says column encryption setting equals enabled, or at the SQL command level, there's a property called column encryption setting, which can be enabled or result set. So if it's enabled, it's the same as the connection string option. If it's result set, it only decrypts the values in the result set, but not in any parameters that you have maybe sent to the server, right? So if you do not want to, if you don't have, for example, if you do where customer ID equals 5, you don't have any encrypted columns in your where clause, so you don't have to send any parameter to your server, so you would use the result set part. And the result set would just decrypt the results coming from the server. Every time that there's a search with any kind of parameter, the store procedure sys_sp describe parameter encryption will be called before executing that SQL statement. This is needed so that it knows if it has to generate any metadata for the decryption of an always encrypted column. So just to show you from the client how this works, I have a AdventureWorks database that has personally identifiable data in it, like credit card numbers or SSN. And if I call it, I will see that I just say read encrypted data. The name is not encrypted, but SSN and the credit card number is encrypted. So I don't know what this is, right? But if you look at here, and what I have done in the code is basically This is just selecting the first two rows, so the thing that you've seen encrypted, but here I am saying where SSN equals some SSN, and I'm saying SQL command column encryption setting enable. So I'm enabling this use of always encrypted from the client. And if you look here, you can have disabled results set only, or use connection setting, which is the default. But I have gotten an error. Now, why have I gotten an error? I have gotten an error because I do not have access to the certificate that I need to decrypt this data, right? So if you don't have the access to this certificate, you try to decrypt, you try to use this always encrypted setting, you will get an error. Now, look at the error. You will see that failed to decrypt a column encryption key using key store provider MS SQL certificate store. The last 10 bytes of the encrypted column encryption key are some columns. So you could say that this is potentially leakage of data. It is, but it's acceptable. And of course, you would never have to. You should never send these errors to the client at all. You would always have to have a custom error page on your websites. So I hope everybody is using that. So the way we solve this, we go to the always encrypted. This is the certificate that we have to import. So basically, I'm just going to import it into my personal store, and the password is brilliantly always encrypted. Next, automatically select, so it will be put into my store. Finish, import was successful. So now let's rerun this, and we can see the same thing as before. We've seen encrypted data, but we have successfully read the decrypted data. Right? So this is all you have to do from the client. So if you have this access to the certificate, you will be able to read this. If you don't have, you will get an error. And of course, if you don't use column encryption, you will just see encrypted values, which are random, so you have no correlation between different encrypted values, so you cannot do any kind of attacks on the encrypted values. And this is it. We have 5 minutes for questions. So if there are any questions, let me know. If not, I'll wait for a while so you can type up your questions if you have them. So this is basically a few gotchas that this section is basically a few gotchas that I have seen in the last 10 or so years while doing .NET development at various clients, and it helps to know these things, right? Because there's always a good knowing how to solve a thing in multiple ways, and so it gives you options. It's always a good thing to do.
Okay, Mladen. So if no one has a question, I might have one. How many people have you seen using these techniques in actual production projects? Have you seen many people already using these techniques, or do you think it's still rare?
You mean all of them?
Well,
so okay, I'll just go one by one. I'll just go one by one. So the async SQL data reader, for example, I have seen people slowly started using it through Entity Framework. So, but not everybody likes ORMs, so they have started using it directly as well. But this is usually for new projects, because all projects are not usually in .NET 4.5, so it's either .NET 3.5 or 4, where you cannot use this. So I would suggest this being used for new projects. Of course, because this is not very known in the database world, I am guessing not a lot of them, not a lot of people use it so far. But there is a lot of education going on about this to the .NET developers from .NET developers, right? So I'm expecting the rise in this. The batching of commands is something I have rarely seen, because the problems usually get solved in a different way, but sometimes you need a solution to a problem in a different way, and this is just a good thing to have in your utility belt. So the idea that you can do this is always good, because you can use it to somehow solve your problem. The transaction scope I have seen a lot. The connection pooling is used by default, so everybody uses it. But as best practice is that you should always specify your transaction isolation level. I am seeing this in about 30% of projects that I've seen in the wild. I explicitly use it on all of my projects. As for always encrypted, yeah, that's not even remotely being used because it's so much, because it's still very new. As for client statistics, I have seen that being used twice because they needed the client statistics from various apps that they just didn't want to, they could offload that processing to the client.
Okay. Okay, great.
So yeah, I mean, people are using it. It's good. It's the thing I said is it's good to know that you can do it in this way as well.
Okay, so it has been a great session. Do you want to talk about something else? We still have a couple of minutes.
No, yeah, questions. I'm guess. Oh yeah, coming up, overcoming a culture of fear ops by adopting DevOps. So
okay.
yeah, that's next. No, I'm pretty much none. So we can either wrap up if there are no questions, or.
Okay, sure. We can do that. No questions so far. Okay, so this is a wrap-up for your session. Thank you very much, Mladen. Everybody who's watching, we still have 3 sessions left. So coming up, as Mladen said, we have Amish Watson with Overcoming a Culture of Fear Ops by Adopting DevOps. And also, your opinion is very important to us. Please fill in the evaluation forms that will pop up when the session closes. And thank you very much, everyone, for attending.
Yeah, thank you.
Okay, thank you, guys.